Greetings and namaskar to each one who came here to watch this video. Today's topic is projection operators. Let's take an operator P. Then there are only two conditions possible when it is said to be projection operator. So the projection operator P is equals to Hermitian and equals to its own square. That is, P equals to P dagger and P equals to P square. Then that operator P is said to be a projection operators. So these two conditions will make an operator a projection operator. Now the simplest example that we can take under projection operator is the unit operator, that is I. So we know that the simple matrix form of I is 1 0 0 1. So let's check how it is a projection operator. The first condition should be I equals to I dagger, where I is 1 0 0 1. So how we change it into a adjoint? It's simply by changing row into column and column into row. And we will get 1 0 and 0 1 again. So this verifies the first condition. Now the second one, that is, it should be equal to its own square. So I equals to I square. Again I equals to 1 0 0 1. I square would be 1 0 0 1 multiplied by 1 0 0 1 again. And we will get 1 0 0 1, which says that I equals to I square also. So from here we can say that P operator is equals to P dagger equals to P square. Now coming to the properties. Number 1, if we have two commuting projection operators, that are P1 and P2, then their product will also be a projection operator. So let's calculate P1 and P2 adjoint. Then it would be equals to P2 dagger, P1 dagger. It will give P2, P1. And we know that we can write it as P1 and P2. And second condition, that is taking its square, P1, P2 whole square, it will give us P1, P2, P1, P2, which is equals to P1 square and P2 square. And we know that we write P equals to P square. So here comes P1 and P2 simply. So the product of two commuting projection operators P1 and P2 is also a projection operator. Now number 2, the sum of two projection operators is generally not a projection operator. Why so? Let's take an example. P1 plus P2. Let P1 be 1 0 0 1 and P2 be 2 0 0 2. So when we add these two matrices, that is 1 0 0 1 plus 2 0 0 2, it will give us 3 0 0 3. Let's take this value as P3. So now let's check quickly whether it's projection operator or not. So let's first take adjoint of P3. So it would be equals to 3 0 0 3. So yes, it is following the first condition. Now the second condition, P3 square. We know that we will get the value 9009 after multiplying the matrix twice. So here we get that it is not equals to P dagger, means it follows the first condition but not the second one. That's why the sum of two projection operator is generally not a projection operator. Number 3, two projection operators are said to be orthogonal if their product is 0. So simple. We know that orthogonal is when we get 0 as the value of product. So if we are getting 0 as a product of two projection operators, then they are said to be orthogonal. Now number 4, for a sum of projection operator like P1 plus P2 plus P3 and so on to be a projection operator, it is necessary and sufficient that these projection operators be mutually orthogonal. So after adding many projection operators, we will get a projection operator. That will be a projection operator only when product of P1 and P2 should be equals to 0. Similarly, P2 into P3 would be 0 and so on. Then it would be equals to the projection operator. That's it under the projection operator. Hope you found this video productive. Thanks for giving your time here. Take care.